Today we are going to learn about what are the stages in making a Unix shell from scratch using C language. The prerequisites for this project is C programming basics, memory management in C, and kernel process management. Moving forward, here are going to be the three major steps for the project. First, getting the input from the user. Second, passing the input. And third, using the passed input to execute the command or the process. Let's go through the entire thing step by step. First, we should take the input in form of line and store it using pointer data structure, for which we are going to use fixed size blocks. If the line is too long to fit in the allocated block, then we reallocate memory using reloc function in C, doubling its size for the line. Once we have stored the entire line, we now parse the input to separate the commands from the arguments. For this, we use tokenization method, which is a common technique used in compiler designs and natural language processing. We use slash w, slash t, slash n, white space or blank space as separation factor, and we store common keywords in different memory location and arguments in a different one. Now, since we have to run our custom shell commands, we have to replace the existing kernel process for which we use fork, where it replicates an existing process and term it as child process. Hence, we replace the child process while execution our own custom process, and we use wait PID system call, which puts the parent process in sleep state to avoid any interference with our process. To execute our program, we are going to use excvp system call function. It is variant of exe system call function as exe has been deprecated. There are two types of process. One which required communication with the kernel such as cd command, which we execute using system calls, and other type is process which can be run without any kernel change such as ls command. Once our program is executed, it signals the kernel to get parent process from the sleep state into the ready state. And as soon as all the command is been executed, all the commands are been executed, then we free up the memory which has been allocated in the first step. Now, since we want the entire thing to simulate a real Unix shell system, Unix shell kernel, so we put the above steps into the loop such that after the execution of each command or process, it asks for the user input again, just like the real life kernel. Now, here is the code for the project. I have implemented cd, pwd, echo, read, and exit, which are the built-in functions or built-in commands, which means they need the communication with the kernel. And I have used the term built-in as to indicate that. And there are also external commands such as ls and other ones. So which can be executed without communicating to kernel, so that it can be just written as a function and not any system call is used. In this function, I have used in this function get input. I have done memory allocation of the input from the user, and I have also done the memory reallocation here if the user input is bigger than the allocated block. Here I have done tokenization in this function get passed. Here we are separating. We are creating a replicate of the existing process, which is done by the fork system call, which gives process ID. If the process ID is equal to 0, then it is a child process. So to replicate and execute that, or to replace and execute that, we use exvp, which is a variant of exe system call. If the process ID is in positive, which means it is a parent process, which we allow to which we put in this sleep state, such that it won't interfere with our program. Launch process is a function where if it is not a built-in function, then it is a external function. So we use this one, and this is the main function where all the structures and the pointers are been defined.